the Gartner Hype Cycle. You know, these consultants that they are doing really, really nice graphs and also predictions that, well, let's see in 5-10 years if they are right or not. But it's quite nice. So, and this graph is just predicting what technologies are going to have a strong impact in 5-10 years in different sectors, not only one, in different sectors. And if you look at this graph, you see, for instance, here biotech, artificial tissue. You can see, for instance, autonomous vehicles. You can see here driving level 4 also in autonomous level, or even biochips. So what these novel technologies has to do with agriculture? This is the first question that we make to ourselves. So at the beginning, it could like, okay, this is for automotive. No, this is for aeronautics. This is for medical and health. But it's not true. It's also for the agro and the food processing sector. For instance, here in Idonial, we are working with artificial intelligence, also to be implemented in farms, in green farms. For instance, we are working with autonomous robots that can also implement vision systems that can detect whether a tomato, for instance, is well mature in order to be processed or not, or even to remove weeds, which can be done also autonomously. So, for instance, we use artificial intelligence, we use connected systems, and also we develop our own sensors, totally bespoke and customized sensors for those farmers that want to control some specific parameters that is important for them. So artificial intelligence, I'm not saying it's 100% implementable in the agriculture, but it has something to do with this specific sector. It's the same with virtual reality and augmented reality. I think in the other technology center you have seen already some examples, but even lean manufacturing. Something so simple like lean manufacturing, how to optimize the production. Here in Idonia we are working with farmers hand by hand, how to really implement what is now implemented in another aeronautic or automotive sector, how to implement it in the farms. And there is even a methodology which is Lean Farm, which is now being implemented in another European countries, and it can be also done in this sector. Optimization of the production. There is another which is autonomous, driving level 4. So we thought, okay, it's possible for engineers to adopt and to do something that can really have an impact on a farm. And then we discover SVMAC. SVMAC is in a startup. Just 3 guys. One of the 3 most talented engineers I've met in my life. So they have been able to develop from scratch, a totally automotive and autonomous vehicle in order to remove weeds. Like, do you have this vacuum cleaner that can go, like it's called here Roomba, right? Well, it's a Roomba, but for a farm, right? It's a large one that you can really program and autonomously is doing the non-value task within the farm. Now it's going to be checked and validated in a farm of 3 hectares, and let's see if it doesn't kill anyone. But anyway, this is the first step that we have the development, and there is a lot of engineering, there is a lot of ICT over there. And we are talking about the engineering that are thinking how to improve the productivity of farms and the food sector. Another trend and technology, biochips, novel materials, nanotechnology is over here, nanoscale 3D printing, how we can implement nanoscale and 3D printing in the agro sector. So we had developed optical filters like paintings that they were developed not for the agro sector, it was developed for the construction sector. It's a paint that you put in the windows, and when the light is projecting on the windows, it's able to cut the wavelength of light. So what it's doing is just moving the light to the edges of the window, that you can take those photons and convert it in electricity. Nothing to do with agro. But then we had an idea. Why not to use these optical filters that are able to really distinguish different wavelengths, and even to move one wavelength to another one from red to green? Why not to use it on the surface of the greenhouses, of the plastic of the greenhouses? Because the plants are not growing, are not taking advantage of the whole spectrum of the wavelength. It's only red. So imagine that when the light is just projecting on the plastic, there is a lot of energy that is lost because the plant is not using it at all. So what we did was to develop a novel film based on nano that is able to convert 5% of the green light to the red one. So what we are doing is just to improve the productivity of plants. And 5% could seem like a very small percentage. It's a lot of money. It's a lot of money, especially in areas here like in Asturias, where the sun sometimes, well, many times, is vanished, right? So this is another example. And also we have used nanotechnology in order to avoid anti-fouling and also like a biocide in the drying, the wetting of tubes of the system for irrigation. So here, for instance, the idea was to put some silver nanoparticles in order to reduce and to kill some part of some bacteria which are not desirable for farmers. And this has been proven in real conditions. And another one, so again, two technologies that can be applied to the agro sector, just for ourselves. So I imagine there are a lot of examples outside that can be applied over there. Biotech, artificial tissue. Everything is connected in this world, everything. So we think that autonomous vehicles is not affecting bioprinting or new technologies. Look, just some example, nothing to do with agro, but I've attended a conference about autonomous vehicle, right? And the speaker said, the autonomous vehicle is going to be here, at least semi-autonomous. It's already semi-autonomous. When you are driving your car, if you have another car, it's always trying to put it in the right lane, for instance. And this semi-autonomous car will be able to reduce mortal accidents by 60%. It's a lot of percentage. 60% just because the car is going to drive semi-autonomously. And then 15 days after that conference, I attended another one related to the medical sector. And there was one guy saying over there, 70% of the organs that are going to be transplanted are coming from traffic accidents. So, okay, we are not going to have organs because we will reduce the accidents, but at the same time we need transplants and we need organs. That's why humanity is amazing. That's why people are working in bioprinting, because later or sooner we will need to build our own organs. Technology is over there. And it's not going to be in next year, it's not going to be in 2 years, it will be in 10 years. But humankind is able to do these kind of things, always applying technology to this kind of needs. And it happens the same with the agro. In agro, we are working with bioprinting. You will see in our lab downstairs, in the lab tour, that we develop, as engineers, we develop our own bio 3D printers, able to process living tissue. Not only for pharma, because we are working with pharmas, and also with a very famous company of candies that they are very interested in putting pharma for kids, but with really nice figures. For instance, like teddy bears here, or hearts that they have the principal, the farmer, and then the kids will be less reluctant to have the pills because it's going to be quite more fancy. And this is the bioprinter. So from the engineering point of view, what we are providing is not the bio ink, it's not the living tissue, it's not how to make alive the stem cells. What we are doing from the engineering point of view is how to build the machine capable of processing. That's why it's very important to combine different knowledges. Here in Idonial, 90% of the people working here are engineers. But we also have chemists, we also have geologists, we also have physicists, and we have even one pharmacist. So imagine how they can really deal with engineers. Poor girl, right? But that's true. So because it's very, very, very important to combine all those knowledge. But bioprinting is also in the sector. And also, there is a lot of money behind bioprinting in the world. We are talking about that sometimes, in order to genetically modify some products, it's necessary to do 3D testing of the system, of the cells, of the agricultural cells. And nowadays it's not possible. You have to just the possibility to deposit on a two-dimensional monolayer, and you cannot do the test in a 3D living body. So the bioprinting can do that.